Hi all. In this video, we see a paper titled Hybrid Trajectory Planning for Autonomous Driving in a Highly Constrained Environments. So this paper uh, says that they have developed a novel and efficient hybrid trajectory planning having four sub modules. One is the development of derivative free based modification in the global path generated from any global path planning algorithms, considering the highly constrained obstacle environment. Once that global path is generated, they use further not a single stage sampling, multi-stage state space sampling, coupled with the optimization based velocity computations. And also they claim that they have developed an efficient, computationally efficient and optimal collision checking to execute this multi-stage sampling with the global free path modifications. So the introductions, they says that human are prone to errors, and they have more traffic congestions are developing, and one of the optimal solution would be to develop a level 5 autonomous vehicle, and that way the people who cannot able to drive themselves can also be get benefited by this level 5 uh, autonomous vehicle. One among the key module to develop this autonomous vehicle is to do a trajectory planning. The trajectory planning is means refers to finding an optimal path by minimizing certain objectives subjected to certain constraints like task constraints, geometry constraints, and the constraints of the vehicle like Ackermann steering constraints. And moreover, they have to be computed in a polynomial time, because this constraint based trajectory planning is an optimization problem which is a piece space hard. So usually an approximation techniques is utilized to find out these optimal solutions for the trajectory planning. So there are basically three based method to compute the trajectories. One is sampling based method, the second is search based methods, and the third is optimization methods. So sampling based method is again can be distinguished to two types. One is a random sampling method, another is a deterministic sampling methods. So example of random sampling method is RRT, and the reference paper is Quata from MIT. And further development of RRT is RRT star. And another one of the random sampling method is a probabilistic roadmaps. So one of the advantages of this randomized sampling method is probabilistic complete. It means that the resulting path is complete, but however, this can be tends to be a jerky, and it is not like kind of satisfying the non-holonomic constraints, or it the curvatures are not that smooth enough. So the other method is deterministic sampling methods. It again, this method is can be further categorized into control based state sampling method or state space sampling method. So in this in both the things, what they do is they set up pre-goal locations, and according to certain factors, they generate multiple paths or multiple arcs which are collisions free, and the objective is to assign a cost function to each path, and choose the path which has a minimal cost based on the collision and the distance to the reference path. So control space sampling method usually tries to discretize into time space, and for a certain time interval, they try to compute for each time step they compute an optimal actions like velocity and angular velocity. By that, they generate many curves based on the reference path, and they also compute the cost functions based on how much distance from the reference path and the smoothness and also the collisions free, and the best path would be chosen from that. Similarly, the state space sampling method also generates multiple paths by solving a two-point boundary value problems with predefined curve model connecting the initial state and the set goal state. So both are generating multiple paths, and the best path is chosen based on the cost functions. So um, So one among the disadvantage or limitations of this one is it has to go for a very long predictions. So do well to have the long predictions, it may unable or inefficient enough to handle a very tight constrained things, and also certain topology is are very restricted in order to do this single stage state sampling methods. So the this search based method is, as usual, we would have seen that it's like a global path planning methods, like computing an A star or a lattice space state lattice method or registrar hybrid A star method. One good advantage is it's like generating a grid at a single stage at the initial one. Then from any node point, we can able to compute to the goal point of the shortest path using that the pre-built graph, which is directed connected uh, edges. But one disadvantage is this find global path is doesn't satisfy the holonomic constraint, and since it is developed from the discrete one, they are not very smooth enough, and they also suffer from curse of dimensionality. And moreover, for a tight constrained environment, generating a collision free global path planning is a big challenging, along with the poor at dealing with the kinodynamic constraints. The last one is optimization based method. One, this is something like again that related to the state sampling methods. We are going to solve a two space bounding problem, but unlike that one here, they what they do is they uh, parameterize the curve that has to be the best path, and the one single path you solving the nonlinear optimization problem is generated, and that parameterized values are helpful to generate the final optimized value directly. But the challenge is for the constraint for the complex geometry shapes, it's very hard to find the optimal solution. There may be stick with the local minima because of the high nonlinearity and the high and also it has very limited ability to handle the tight constraint obstacles. So, what are the contributions? Here, they say that they proposed a hybrid trajectory planning algorithm by combining the strength of different methods. They have given some four contributions. The first contribution is once the global path is generated by any algorithm, they do go for a smoothing process and also modification such that the collision-free smooth global path is generated. Modified path is that is being fed into a spatial path planning, which is not going to give you a single stage, but it is a multi-stage state spatial planning path planning method. And they also decouple the velocity computation from the path planning method, and they improvised objective optimization with speed planning layer. And finally, they claim that they have an efficient collision checking method, which is computationally very efficient. So these are again things they have given in a itemized manner. The four one that we have highlighted here: path modifications, multi-stage stat sampling, optimization based speed planning, and hierarchical collision checking. So this methodology being given in the figure 3. So once the global path is comes into that, it is being modified by the global path planning wire, and the multi-stage multi-stage state sampling method is being improvised. And again, the speed planning is improvised, and the collision checking is utilized based on the occupancy grid map. And finally, we are getting a trajectory for the tracking. So So this is the overall idea of that, and each and every, they have some four sections for these four contributions. The first one is like they use a space exploration algorithm for making a global path modifications, which unfortunately we don't go deep enough into this algorithm three, algorithm 1 and 2, and also 3. So the more attention would be on this paper is related to the multi-phase deterministic state sampling. So what is this mean means it's same like a single stage state sampling method. The single stage state sampling method is something similar like solving two-point boundary value problems. So what they try to do is they make a goal point, and they make then they laterally offset for different points along this one, and they try to find or try to connect the best path from this initial point to the different goal points. And once they try to connect it with the certain objective like minimizing the curvature, minimizing uh, uh, the path, the minimizing the time, all those constraints have been added. Then from that, which one is having a minimal cost based on the obstacles and other constraints are added. Then among this path, among this trajectory generator, the best trajectories in related to the obstacle, in related to the distance from the reference path is being selected. The but what they have claiming is, if it is a single stage, it is subjected to a very, if it is a single stage, it is subjected to putting for avoiding a tight constraint obstacle. We have to generate various number of trajectories. For example, if it is a free space, a fixed number of trajectory would be sufficient enough. But if it is a tightly constrained environment, we don't know how many trajectories we needed to generate dynamically in order to choose, in order to or generate to in order to identify the path which is collisions free. So in this case, if we are having a fixed number as earlier determined like this along the red zone, it will be highly impossible to generate a path. Then again, dynamically we have to generate additional vehicles, additional paths in order to identify the collision free paths. So this gives unnecessary computational overhead during the real time process. So what normally to avoid those things, they did a multi-stage state sampling method similar to what it has been seen in the figure 8. So for each path is generated based on defining the curvature in a define the curvature with this parameterized curvature, arc length parameterized curvature, and then x, y, and theta is defined based on this arc length parameterized curvatures. And once that is been done, then this will be the, these are the parameters that has to be optimized from the starting point to the end point. And further, it has been reformulated to for a computational advantage into this type of parameters. Once this been reformulated, and we try to solve an optimization problems from the starting point to end point. And once that is been solved, and we generate different trajectories, and based on that single stage, then the second stage and further the end stage will be computed similar to the single phase. So once that is been done, we improvise the cost functions, and we try to find out which would be the which would be the best function based on the collisions, and also the curvature continuity, and also how far it is from the reference path. Once the path is computed, then there will be another optimization problem is being invoked. And this acceleration and linear acceleration and linear velocities are parameters like alpha s and beta s based on arc length things. And they are trying to solve this minimization problem to identify the best uh, velocity values. Then they also say that based on the occupancy grid map, they have generated a collision efficient collision based algorithms. So these are the contributions. One is the global path modifications as defined in this figure. Sorry, I have to scroll up again. So this is for example, if the global path is given, this is the global path modification algorithm. That is the one thing. Based on that algorithm 1, 2, and 3. And the second one is multi-chase sampling. Instead of a single, the generated path will be very coarse. So they do some kind of smoothing, and they make multi-stage sampling similar to like this. This is the original global path, but what they do here is, if they wanted to make a modification globally modified layer here, they make this trajectory sampling, but this is single stage. But what they do here is multi-stage sampling, similar to the other one. Then the third contribution is velocity optimization based velocity computations, based on this minimization algorithm equation number 19. And another thing is an efficient way of collision checking, which we don't have enough time to go through this one. The major part would be that multi-stage and global modification layer. So they tested these results in a simulation based environment, and the thing is they compared the results with the hybrid A star and CG based smoother. There are three types of CG based smoother they did it. And also they also invoked single phase stage sampling methods, but unfortunately those methods for this tight curvilinear path and for this tight constraint, they couldn't be able to achieve the reasonable results, so they are dropped, and only wanted to compare with the hybrid A star and the MCG method. So when they are trying to compare with different stages, one is wanted to the first test case is something in a very curvy road without obstacles, and they claim that the shortest path developed from this algorithm is much better compared to the hybrid A star and the MCG method. And the second test was based on a very curvy road with the dense obstacle, but they are statics. And in this also they claim that the shortest path and the way they computed in a terms of time computational efficiency also seems to be much better than the LCG, MCG, and SCG method and the hybrid A star. And these are the table summarizing how what is the length parameter computed from the different way. And the multi-stage sampling is comparatively less length to the other one. And also the how much the curvature and all those informations are given here, and it has coming an optimal solutions in comparison to the traditional hybrid star and the CG smoother method. So these are the results they have done, and the conclusion is yes, they have developed some novel and efficient hybrid trajectory planning framework to handle the geometrical constraints and dynamical constraints nicely in a human-like manner. And the four stages is derivative-free global path modifications and reference path generation, from the reference path generation. And they have improvised a multi-stage sampling method. And third one is they have tried to give efficient collision based algorithm. And also they have separated the velocity computing from the state space coupling, and they have used optimization based velocity computations. And they also compared with the results with the hybrid A star and CG in a simulation environment, and claimed that this method is giving a very short length and an efficient in efficient uh, time occupations. So the future one is they haven't considered for handling the dynamic obstacles, but that can be easily handled, uh, making a more kind of frequent updates. But in future they have a plan to have a separate investigations and research on how to handle this lateral and longitudinal motions to avoid the dynamic obstacles smartly and efficiently. Thank you.